Swayam Prabha. Digital India. Educated India.
We will continue our discussion on grouting in this class, and I would be talking about chemical grouting, which as I just mentioned is that when the particle size is too fine, you need to have chemical grouting. In fact, there is a committee on grouting, as I just mentioned. There is a lot of activity in international level, where International Committee on Large Dams is there, then International Committee on Grouting is there. There is a group on ground improvement techniques, which is called Technical Committee on Ground Improvement Techniques. They have some rules, and the chemical grouting is defined as any grouting material characterized by being a pure solution, and then no particles in suspension. That is one definition, but in practice what we say is that it is not just a solution like a chemical solution that you have. You need to have some sort of suspended solids also to see that in the way that it is supposed to be beneficial. So what we say is that it is the more of a solution, and we have many types of grouts here, which are chemical grouting, as I just mentioned. Actually there is one reference by Carroll who did lot of work on these lines, and you have a lot of chemical materials here. It is called, they have sodium silicate formulations, acrylics, lignosulfates, lignosulfonates, phenoplasts, aminoplasts and other materials. Actually a lot of material is available on this. As I just mentioned, it is a good treatment method for a low where you need a low viscosity, when a low viscosity, like the particles can go slowly into the pore sizes, and then because of the chemical action also they can be very effective. And each of these chemical grouts have different strengths, cost, viscosity, toxicity, durability. In fact, they have even some effects also, because they are all chemicals. The major difference between the particulate grouts, like we saw, bentonite or cement, and some of them, they are all more particulate grouts. They are called particulate grouts, and the chemical grouts is the penetration characteristics. We call it penetrability. The chemical grouts can penetrate into soil with finer particles. The penetrability for chemical grouts is a function of the solution viscosity, whereas penetrability for the particulate grouts is a function of particle size. This distinction is very necessary, because when you are trying to design a grout, you should know what is the size of the particle there. Then if the size of the particle is going to be very little, somewhat coarser, then one can go for particulate grouts, means particles which can be in a suspended form, they are bigger size. But when you want low viscosities and other things, like the particle size being very low, you need to go for chemical grouts. This distinction is very essential. You can see that the grouts, chemical grouts have a big variation. You can see that gravel, sand, coarse and silt sizes are here. The cement could be just applicable to this range, cement, but cement plus bentonite or bentonite alone could be somewhat higher. Then polyethylene and polyacrylate properties, they have somewhat higher. You can see that aminoplasts and others, acrylites and something, they have a bigger range of applicability for depending on the particle size. Say for example, this material could occupy or serve a big range of particle sizes ranging from gravel to coarse silts or clay soils as well to some extent. And whereas a compressed air also, like you along with that you inject compressed air into the system, the possibility it enhances the whole issue, like it can be useful to some extent in some of this grouting system itself, like to increase efficiency. This is another table that one should have a look at it. Depending on the type of chemical grout, as just mentioned, it could be sodium silicate or silicate, lignochromes, all that you have varieties of materials. Their properties are also here given, and then depending on we know that the viscosity is in terms of the kilopascals or pascals, the unit of per this thing. So, you will see the per second actually. Gel time is something that we need to understand, that what hardening time or setting time. So, you in minutes it is given. Polyethylene, it reacts instantly with water, whereas aminoplasts they take some time and all that. So, strength in coarse sand, what is the order of strength they get? You can see that they have some it is quite good in MPa, it is very good. Like unconfined compression strength of say clay or sand could be very low, it could be just even 1/100th of this or much less than that. So, but then by adding this some of these materials, it gets improved by this much number, which is quite good. And there are some issues that are like as I said, risk and toxicity, because they are chemical in nature, and so there is some risk associated with that. It can be a risk in terms of the skin allergy and all that. It is a silicate, of course, a household chemical. Phenolic resins, respiratory irritant, caustic. So, in some places it is also banned, like acrylic resins, they are all banned neurotoxic. Okay. Then respiratory irritant and all that. So, when somebody is trying to chemical grouts have been effective, but it does not mean that they may, if you do not take proper care, the possibility is that they may affect the health, human health, or operating persons are there. So, but otherwise they are okay. Like when you are trying to operate, during that one should take care of these health hazards, then otherwise it is all right. So, some of the remarks are also here, that how in what form it is better and all that, in the sense. So, for example, silicate, only 1 or 2 stable gels of high penetrability are there, and lignochromes, hexavalent chromium is an accumulative pollutant and needs clarification to remove particles. The other chemicals they have a poor gel time control with high strengths, some certain needs, one should really do some sort of analysis, because the fact that you have so many chemicals does not mean that you can use them directly. They need to really do one should do lot of studies with the chemistry background, and see that they are very effective and also do not have difficulties when you are trying to handle it in the field. So, I will give small examples here. This is in Michigan State, one construction company has done that. This is a tunnel, and then it is about to be it is caving in. It is about 31 meters long, 6 meters diameter, was constructed using the new Austrian method of tunneling. In fact, this is one method for construction of tunnels. Because the site's conditions primarily consist of fine sand, chemical grouting was specified to stabilize the sand and enable open face tunneling. So, in this case, since a fine sand material is there, definitely it caves in, and to increase that strength, when you are trying to do tunneling, like it is open face tunneling, what we call. So, one should stabilize it. So, that company stabilized it with a sodium silicate based grout. The chemical grout was injected through 41 tube manchet sleeves, each one over 100 feet long. These mission sleeves were drilled horizontally into to maintain an active undisturbed roadway above. The thing is that it is placed ahead of what you are trying to drill, and the chemical grouting process created a treated mass of stabilized sand, so that the tunnel could be excavated with less risk of overburden collapse. Like the moment from the front side, like as I just mentioned here, like if you are able to stabilize the area much before you start tunneling using this process, then it is fine. So, that is what this company did. It is a very important case study, it is a very good case study that is very applicable to many of the conditions that we have in underground water and all that. Another important point that I would like to say is that there have been many case studies, in fact for particularly underground water control. there is some literature that clearly says that the chemical grouting has been studied for about 30 to 40 years, and they are quite effective in controlling the infiltration and inflow of underground water and underground structures. See, there is a seepage also. So, how is it effective? So, some experiments have been done which show that these materials did not show any signs of distress and withstood number of cycles of weathering, as well as they are cost effective. Like, say for example, we always have apprehensions about, is it going to be cost effective, is it going to be durable in the long run, because I am just applying a chemical after a period of a few years it should not collapse, does it lead to some other issues. So, all that people have studied at least for some cases and showed that definitely chemical weathering is something that is quite useful. I would like to just stress on some more important points here, that there is a spelling mistake. So, rheology of grouts, it is here. The rheology has 3 considerations: stability, setting time and viscosity, and as I just mentioned, the stability is nothing but you consider the suspension stable if the particles remain in suspension until they reach a destination. Setting time, it is a time required for the grout to harden, and it is in the range of 4 to 24 hours depending on the additive used. And viscosity is a proportionality factor or a constant relating shear resistance to the velocity gradient. Like as I said, there is a force applied, and when you just do that, it should not they are all viscous fluids. Like water is one example. Water has a very poor shear resistance, but when you start adding some sort of chemicals or solids like sands or cement, then it achieves some sort of increase in shear resistance. So, it is also, we call it, we use that simple law of where we assume that as I just mentioned, the coefficient of viscosity we calculate, and this is a simple example of calculation of viscosity here. And suppose you fill up the slurry here, and it has two cylindrical tanks, one is with radius r1 which is inner one, and r2 is radius out, and then it has filled up for a height of h, and we assume that the bottom does not offer any resistance, and we try to rotate this and try to measure the torque to move certain distance similar to our vane shear test. One can calculate the using some simple expressions available in literature, one can calculate the viscosity of the grout. So, that is one can do, like you apply a simple torque here in this manner and measure the viscosity, and that one can do that. In fact, people have been trying to understand that the rheology of the fluids particularly. So, we have what is called frictional resistance, and we say it is a Newtonian model we use, and when you just so what it means is that this is a concept that we have. The way that you want to model a grout is that this the grout has a frictional resistance, and it also, so the moment you apply a force, it has some frictional resistance, and also it has the what is called the viscous effects. So, to model that we use a simple approach, and we call it a Bingham body, and say for example, in this case you start trying to allow the liquid to flow. It has to overcome initial shear resistance, which is we call it tau naught, and then as the velocity gradient increases, then shear stress also increases. This is a simple law. We are familiar with Newton and non-Newtonian fluids. This we assume that it is a Newtonian fluid. The rheological behavior of the Bingham body is expressed as T is T naught plus mu dV by dz, and this particular thing is called this particular term is called rigidity. A thin plate with rough surfaces is to calculate is immersed in the grout, and the initial stress can be determined from the amount of grout sticking to the surface. We call it is equal to tau naught by gamma. Once the flow time from the cone and the rigidity are known, the true viscosity can be determined. Actually, this is called the rigidity, initial rigidity. And see, the way that we do is that you try to pass between the two plates, and then once you pass through the plates, then and measure the amount of grout sticking to the surface, we know its T naught also could be calculated, and its unit weight is also known. So, one can take that, and also at any point of time one can use this sort of an equipment called cone testing, Marsh cone, in which you try to measure the flow, and once you measure the flow, and there is some simple relationship that is being provided in literature which show that for actually these are all different times, and knowing this initial T naught by gamma, and one can how much time it takes to come out. Flow time is measured for the first liter to flow through, like 1 liter is it's like it's a 1.5 liters capacity. We assume how much time is taken by the grout mix to see that the 1 liter of grout has come out, and once you know the time, and you can find out the flow ratio here using say for example this is all in seconds. So, once you know that, once we know T naught by gamma for that same material, as I just mentioned, T naught by gamma can be evaluated with some that plates arrangement, and one can get an idea of what is the actual viscosity, because the objective is to get this one. Okay. So, you will have this, and you know this, and you will be able to get some understanding of what is its shear what is its viscosity. There are also some more concepts on understanding the gravity the flow of the grouts in terms of the viscous nature and the viscoplastic flow in pipes and all that. There have been somewhat mathematical models. Then coming to permeation, we know that as I said, permeation also needs, say for example, there are two types of models. One is for the strength improvement, the other one is for the permeability improvement or permeability reduction. So, for example, here the permeability grouting of soils can needs to be having an understanding of, you should have an understanding of the spherical flow model for the porous media, radial flow from the cylindrical cavity, groutability of the soils based on permeability. So, there is some sort of understanding that is given here, and the different types of solutions and suspensions, they have different levels of permeation and fracturing, in the sense that their applicability is clearly known. So, depending on, say for example, MC 500 cement and bentonite, to what extent they are useful. You can see that the bentonite is somewhat valid from gravel to sand, whereas cement is only for gravel, whereas this is this is another type of thing which can be little longer. Similarly, in the case of solutions, this is another one that it is valid for wide range of grain size distribution as a permeation grout. So, this is actually, if you just see the previous thing, I was talking about the three materials. One is called ordinary Portland cement, other one is a colloid cement, in which a colloid is added, like bentonite is added. The other one was that another compound, it is just an example to see what is the viscosity, how does the viscosity alter with water cement ratio by volume or whatever. So, one can, this sort of laboratory work is important to understand, because the thing is that finally you should be able to do the mix design properly, in the sense that you should be able to fill up all the cavities. Say imagine that there is some space available roughly some meter cube of material, that pore space needs to be filled up. When you need that much of pore space, and you should have some time also, and then it should stabilize. There are 3 issues there. One is space available to fill up all the pore voids, and also the grain required is another thing, and the setting time. The thing is that it should set little faster, like if it takes long time, then it is no use. So set faster. So maybe suppose you want to construct this particular work in about start the work, and at least 2 days ahead you must be able to complete the whole of that, and we should expect that that material got stabilized, and then you can start excavating there, so that you can grout or using some of these methods, and then start, so that working on, say for example, a tunnel project, so that it is safe. So the important criteria is that you must have some sort of design, tentative design, in which you have the rough area of the pore spaces to be filled up in terms of the volume, and also the properties of the grout, and also like this all based on your grain set distributions and all that. This criteria we have already discussed. One should be able to establish some of these things very clearly, and also it depends on the cost effectiveness also, like as I said, the viscosity, you can see that the this material has a low viscosity compared to high viscosity. So how much do you need what viscosity you need, so that it fills up all the volume should be little, one should have a knowledge of that. Okay. So it is very important to lot of mixed design procedures and come out with proper understanding, and one should do lot of laboratory work also. It is not just that the concepts are simple, because I have seen that things are generally empirical here, and we should be able to verify based on certain laboratory tests, and see that you come out with a proper mixed design of the grout. Suppose in the case of rock joints and fractures, the thing is, this is a very typical case in many problems in rock slopes, and there is some sort of understanding also one should have, and the thing, why is this concept of viscosity and its things are required, is that you must be able to design in some sense what is going to happen. So in this case, particularly for rock grouting, permeation grouting, when you are trying to use for rock joints, we assume that you have this gravity, the discharge here, then it exerts some sort of pressure here in the form of a 2D, and you must be able to calculate the grouting pressure and uplift force in a joint, because it should not lead to hydrofracturing. Sometimes if the pressure is going to be higher, it could lead to fracturing of the rock itself. So one should be careful in some of these things, and depending on the type of rock, we have different permeability coefficients and the porosities. So in fact there is certain thing that you apply some pressure, you measure the flow rate, and actually the amount of discharge is measured in terms of the Ludgens, its Ludgen units, where you try to do the in situ testing of permeability of rocks, and you apply some pressure and then monitor the flow rate. So as you increase the pressure, the flow rate increases, and as a pressure is withdrawn, the flow rate decreases. So in this case there is no problem. So this is similar to an elastic soil behavior, in which the exact say it did not lead to any fracturing problems and all that. So but then I can show you there are some cases where one should, based on the type of the response you have, you can understand what type of flow it is, what could happen and all that. This is a typical diagram in which if the pressure is applied and the flow rate is monitored, this is a laminar flow. Okay. In the case of a rock slope, this is a laminar flow, in which, because there is no much damage to the rock and all that, and if there is a curvature here, we call it turbulent flow, like it all depends on the size of the rock joint. Then there is another example here, expansion of the fissure or hydraulic fracturing. What it means is that you applied some pressure, but during the unloading process, for the same pressure you have high flow rate. You can see here that I just take the pressure at this point, and if I just see the flow rate was less here, but while but then when during there is a higher flow rate in the unloading process, which means that there is some sort of expansion of the fissure or hydraulic fracturing is there, which means that the pressure was higher. Then another case was that like there is another possibility that you just apply the pressure, then apply some more pressure, then the possibility is that then come back, then what happens is that the flow rate is still higher and it is somewhat not sudden, and it shows that the washing out of the filling in the fissures. So, in a fissures in a rocky joint there could be many materials, and you probably removed lot of the filling material in the during the testing. That is what it shows. Like it only shows that there is lot of filled up material in the this thing. So, these are all in situ tests. Then there is another type that is called blocking of the fissure or the swelling of the rock. In fact, like see this is one type, like you increase the pressure, then during the reversal you see that the flow rate is much less, which means that which is unusual, like in the sense that we say that there is a swelling of the rock or the blocking of the fixture. So, there is a somehow the block got there was a block in that area, and that so sometimes you may see that there could be people use this term called swelling of the rock, which is somewhat confusing, but then that is one of the terms that is used in rocks as well. So, these are all some. So, based on some of these tests one can understand what is the pore size or what should be the permeation grouting that is required, and one should have. So, this some of this information will help great deal in trying to design how to close these gaps. So, now I will just take up some more examples on the compaction grouting and jet grouting, because as I just mentioned these are all very popular techniques. As you have seen just in the video as well as in the some discussion, we saw that compaction grout we have, it is called low mobility grout, and it displaces and densifies the loose granular soils, reinforces soils and stabilizes surface voids and sinkholes, and it displaces ground and improves the ground conditions. Like you can see that compared to native soil here there is a densification achieved here, and then there is a bulb formation also, like it reinforces the soils to some extent, though we do not really calculate its how much of reinforcement contribution is there, because we know just exactly we try to what I just mentioned was that its densification is one important property here, then strength improvement by forming this column is also another important variable here. So, all these things will greatly help in reducing both permeability as well as increasing the strength. So, if you want to do this you need to have very good soil investigation done, and you should have the site geology and history, gradation characteristics and in situ horizontal permeability of each stratum. Typical type and the condition of the nearby structures and utilities together with plan and elevation will also help in the program, because suppose you are trying to do construction the nearby in a highly habitated area or urban area, you need to understand that that cannot be done that easily, and you must be able to protect all the nearby buildings. So, the some of the geotechnical issues that we need to understand also are that the in situ vertical stress in the treatment stratum must be sufficient to enable grout to displace the soil horizontally. Like as I said, the in situ stresses should be somewhat we are using this technique in the case of loose sands, and when you apply this the bulb formation should take place and density should it should be able to expand. If it can't expand, we know that the soil is very good. So, the in situ vertical stress needs to be sufficient to enable grout to displace horizontally. The grout injection rate should also be slow enough to allow pore pressure dissipation. This is another important variable, like it should not be too fast, because there could be temporary pore pressure mobilization, that could lead to a lot of other difficulties. And compaction grouting can usually be effective in most silts and sands provided that soil is not near saturation. Similar to testing in sands near saturation, one should be see that the quick pore pressure mobilization should not be there. So, we should see that the soil should not be close to saturation, and there should be of course, it could take some time because you are trying to densify the system there. Soils that lose strength during remodeling should be avoided. So, for example, as I said, clays they have some strength reduction because of disturbance. When you have disturbance, the possibility is that they should not lead to further settlements. So, we should avoid that type of material. So, greater displacement will occur in weaker soil strata. Excavated grout bulbs confirm that compaction grouting focuses improvement where it is most needed. Actually, what happens is that the excavation, the way that bulb forms is that it goes towards the area where it is weak. So, the bulb formation will be like that, where the improvement is where it is mostly needed, it goes, the bulb formation is towards that. Collapsible soils can be treated effectively by adding water during drilling prior to compaction grout injection. We know that the collapsible soils are something peculiar in the sense that they collapse with the addition of water. So, best way would be to stabilize collapsible soils is that you add water, then there is a collapse of the soil structure, then also do the compaction grouting. So, both combinations of water addition as well as compaction grouting will make the collapsible soil into a better soil, so that one can do the foundation construction. Stratified soils, particularly thin stratified soils, can be the cause for difficult or reduced improvement capacity. What happens is that the bulb formation, if it is too restricted because of the ice, say for example, if they have alternate layers of dense and loose material which are thin layers, then it may not be, there could be efficiency of the process is less compared to a case where you have a lot of loose deposits which are uniform. There you have the best benefits. So, here as you just saw in the video that the procedure consists of drill or drive casing. You put the casing, actually location is very important. The thing is that say for example, this is all the loose stratum, this is a decent competent black fill, everything is fine, but you have a loose soil here. So, location is very important. Record ground information from casing in installation. Like, so the thing is that even the way that you are putting the casing can help you to get some information about the strength of the soil. So, typically bottom up, like what means is that we come from bottom, but sometimes it can even be top down. So, we try to come from instead of bottom, it can be from top also. Grout quality is important. We expect that you have done a good research or good mix design of the grout, and quality is correct in terms of the contractor that say you may do something laboratory work, or then finally the contractor should be able to come out with this material in a proper way and put it. So, pressure under volume, pressure or the volume of the grout are usually limited, slow uniform stage injection. So, you try to inject it slowly that the formation of the bulb takes place and it is quite efficient. On-site batching can aid control, like in the site it can be done in batches. Grout quality is important, pressure, grout quality and indication of the heave are controlling factors. Sometimes ground heaving also could take place. Sequence of the plan of injections point is very important, like where you should start first in this particular plan. Say once you have the total building plans and all that, you must be able to decide where you should start first, because or should you come from how do you like one by one, how do you do that, that is very important. Typically pressures greater than 100 kPa is required to maximize densification. Limited densification can be achieved with less overburden, and this stress can come from overburden soils, surcharge and load and foundation loads. Actually, in some, if the overburden is about 100 kPa and all that, say for example 5 meters, you know what I meant, 5 meters into 18 kPa is about 90 kPa, and so close to 5 to 7 meters or 8 meters, this effect technique is going to be very effective, and limited densification. So the densification is maximum in this range, that is what people have observed, particularly certain companies which have been using this technique very well, and limited densification can be achieved with less overburden. That is what I said. If the overburden is less, there is no confinement little bit. So this stress can come from overburden soils, like if the overburden is there, then it is better, or even surcharge is there, it is better. When densification is the primary intent or the reason, a replacement ratio and the pressure gradient is applied on each stage of the compaction grouting. We try to just put in terms of how much of replacement can be done. It is compaction grouting volume divided by treated volume. If it is 5 to 15%, it is considered to be good. This ratio is determined based on the existing density, the soil density range and amount of displacement required to affect the improvement. So you must have a rough idea of the volume that you are going to increase or influence. Volume you are going to you densify the system. So you must be able to have the approximate volume of the voids that you are going to handle, so that you will get an increase in density later using this ground improvement technique. Then the maximum pressure criterion that prevents fracture and ground heave and compensates for stiff zones they are also important. Vertical stages are usually set to 2 feet intervals. Tight grid spacing generally lead to better results. These are some observations, and the applications are very good. Like as I said, it can be used in karstic regions where you have the formation of sinkholes, and so one can use this technique. The treatment usually involves drilling down to and into the limestone surface to locate and fill any cavities, followed by improvement of the loose soil above the rock surface. These are all many places in Germany and other places I have seen where you have these cavities formed, and it is because of the natural phenomenon, and the cavities can be closed using the compaction grouting. You have a rubble fill like a construction fill, and which are uncontrolled dumps. Definitely one can stabilize using this. To close the void spaces and minimize potential settlement impact, compaction grouting is applied in a regular pattern. This can be done particularly when you have rubble fills. So you should have a rough idea of the void spaces. Again, of course it is not easy, but then you need to have an estimate, because the advantage is that you should have good quality control in the even the measurement of grout going into the system. Then poorly placed fills, like suppose we know that the compaction is not done for the fill well, then if there is sufficient overburden, a proper program of compaction grouting can treat the poorly placed fill material. I have told you some case where 10 meters of filling has to be done. The first 2 meters it was not done well, next 2 meters it was okay, then next 2 meters was okay, but then say when the problem is that after say 5 or 6 meters of depth, suppose you realize that based on the CPT tests or SCPT tests that the soil is not good at location, the best way would be probably that you need to find out its density and back calculate certain things and find out if you can densify that area. So poorly placed fills also could be stabilized using compaction grouting. Then loosened soils, construction generated ground disturbance can often be the cause of loosening. Like what happens because of the construction induced vibrations and all that, there is a loosening of soil structure, and what happens is that if you are able to that could affect the buildings, lot of buildings, like this is a case, in some cases if you try to do some excavation here, there is a possibility of instability occurring, and then that could lead to some problems. So one should really analyze this problem and affect the improvement, and it is possible that you can use this technique and you can inject the compaction ground soon after the disturbance occurs, and it can compensate for the disturbance by re-establishing the original stress and preventing the deformations beyond the working area. Suppose you have known that there is a loosening of likely loosening, one can do the pre-treatment. Like what happens is that there could be ground movements that could occur because of certain excavations and refilling and all that. One could understand that yes, the possibility is that if you remove the soil here, there is a possibility of disturbance of the nearby soil stratum. They may get stress release will be there, because you remove excavation, so much of cubic meters of soil is removed in one area, the all nearby areas they tend to relax, because the soil under their foundation start coming thisward towards the excavated area, and one should stabilize that. So, one could anticipate those things and then stabilize. Of course, it can be very effective in the liquefiable soils also, and ground treatment consists of density increase, cellular confinement and reinforcement. Of course, soil permeability is another important parameter in determining the rate of compaction grouting. Of course, collapsible soils also is very effective, this we can have seen. So, that way the advantage of the compaction grouting are that it can pinpointedly treat the area, speed of installation is good, wide application ranges, effective in a variety of soil conditions, can be performed in a very tight access and low headroom conditions, non-hazardous, no waste spoil disposal. Like sometimes if you use certain techniques, there is a waste also generated, like 10%, 5%, there could be some difficulties of disposal. So, here since you are using a particular grout, there could be a possibility that such possibilities are less here. No need to connect to footing or a column. So, in some cases sometimes it is required to connect to footings or columns if you are trying to use some techniques, but here there is no such requirement. Like you are trying to put some pile foundations. Pile foundations should be connected to the original structure, because they have to take care of the load. Some of the load that is the should be, now imagine that the load is not the particular pile foundation group is not able to take care of the load, and then there is a possibility of differential settlement. So, you need to put additional piles. So, additional piles have to be connected to the original system in which there is a load sharing, proper load sharing. But then imagine that it is not done, like then it is a serious structural problem in that case. In this case, what you are trying to do is that by improving the ground all round close to the pile foundations, we see that the piles are they say, for example, you design the piles based on the skin resistance and shaft resistance. If that is going to be little higher, then it is fine. So, non-destructive and adaptable to existing foundations, economic alternative to removal and replacement or piling. Okay. Able to reach depths and unattainable by other methods, enhanced control and effectiveness of the in situ treatment with another systems. Okay. Just small examples, like in a wastewater lift irrigation scheme, and the shaft was designed as a series of 10 feet deep concrete ring sections installed from top down. Like what you do is that for a water supply treatment plant or whatever, you need to construct vertical shaft. Vertical shaft, how do you construct vertical shaft? You have to have a series of rings, place them. Okay. So, if you want to do this, you have to stabilize, it is not easy to do this sort of construction. Okay. So, because say for example, as I just mentioned, it is a 40 meter deep, about 10 meters, more than 12 meters deep, and about each 30 feet diameter. Diameter of the shaft is about 10 meters. So, the material is uncompacted native silty sand. So, the shaft was designed as a series of 10 feet deep concrete ring sections installed from top, and so the bottom one reaches the designation level. So, for this compaction grouting was undertaken to densify the disturbed soils between 30 feet and the previous this is what they have done. So, what they found was that there were some problems that they were facing during the construction process. So, finally, I mean the problem due to side friction was overcome by air water jetting, and additional fill was placed to restore the site to grade. So, it is possible to solve even construction of some of these issues, construction of shafts, vertical shafts in this manner. So, this is a shaft, this is a structural fill, and this is how it is done. So, normally to do a shaft like this, it is not very easy, like you are trying to do a vertical, like think of a well of say this is 10 meters here. If you want to do that, the problem is that you should design for this earth pressures, and there will be lot of problems, and the soil is so loose. So, the technique was that they said that they are placing the rings. So, how do you place the rings? So, it is not easy, and so what they did was that compaction grout was here placed and stabilized, the whole area was stabilized, and the earth pressure coming on this was less. So, this is how it is done. So, that is about compaction grouting. Now, I will just give some more examples on the jet grouting. As I said, jet grouting has you have seen anyhow 3 types it has, we will see that. Jet grouting is a grouting technique that creates an in situ geometry of soilcrete. We call it, instead of concrete, we call it soilcrete here, using a grouting monitor attached to the end of the drill or stem. The grouting monitor is advanced to the maximum treatment depth, you take it to the maximum depth. High velocity fluid jets are then initiated from the ports in the side of the monitor. Like you have seen, there are single type 3 second and 3 jets are there, and the jet grouting jets will come. These jets erode and mix the in situ soil as the drill, stem and grouting monitor are rotated and raised. So, by in this process the material gets mixed up, and the soilcrete is nothing but it is the material that is densified column, a densified material, it is a grout mix actually. So, the excess soilcrete rises to the surface through the borehole annulus where it is contained and disposed of. This is what it is done, you can see that jet grouting, you have done one in inclined, then the other one is coming like this. See, it has that it creates because of the pressure, it is mixed. So, actually I must thank this Hayward Becker company, in which they did extensive work. I have taken a lot of material from them, where they are able to do this show very cleanly how the techniques are done. Okay. So, you can see that this way it is done. So, this is an example of a soil jet grouted soilcrete columns to underpin and provide excavation support for this wall at Bayer Healthcare facility in Walpur area. Like you have a building here just next to that. Okay. It is not easy to go for an excavation like this, it is so tough. So, they used this method which we just saw just now, see, doing like this, and now there is no stability issue at all. Jet grouting stabilization at another place for the construction of new sewer tunnel, at the another place. Okay. So, these are all the shafts, vertical shafts and tunnels. Actually imagine that you need to construct vertical shafts and tunnels and all that and stabilize the whole area, and it is not easy. These are all very complicated structures. Particularly design may be easy, but doing construction it is not very it's not very easy. It is very challenging, and one should really see that whatever are the geotechnical issues that they not give difficulties in the erection of these facilities. So, depending on the application and the soils to be treated, there are 3 primary systems of jet grouting. A single fluid system called soilcrete S. So, we have a single fluid, the injection of the cementitious grout slurry at high velocity to erode and mix with soil. This was single jet. I showed you that examples, I will show you again. Then double fluid system soilcrete D, we call it, its S is single, D is this thing. The injection of the cementitious grout slurry at high velocity, sheathed in a cone of air at an equally high velocity to erode and mix with soil. So, you have grout slurry plus air. Then you have triple fluid system, we call it soilcrete T, in which you have water plus air plus the grout, 3 of them coming together. It is a single fluid system, grout plus air and all that term, triple fluid system. Okay. There are more variations of these systems than their systems themselves, but in most cases they are a bottom up process, like we try to do from bottom. Okay. This is to say that they use hydraulic rotary drilling to reach the design depth, and at that point initiate jet grouting parameter and produce procedures to create a cementitious matrix, soil matrix commonly called soilcrete. During grouting, the borehole annulus must be large enough to permit unimpeded up hole spoil return. Like while in the annular space, when you are trying to do that, the spoil whatever is it should be able to come up. This allows for the control of the in situ vertical stress environment. A lack of this spoil return will result in hydrofracturing of the ground and the loss of control. Loss of this ground control can lead to extreme inconsistencies in the soilcrete quality and geometry. These are some issues that they have, like again you can see that jet grouting process and the way it is done, single jet, yeah, it is like so this is how it is done. The pre-drilling or the foundation may be necessary to access the treatment zone. Other emerging jet grouting systems include superjet or XJet. There are some advanced systems as well in this case. Superjet system means a double fluid system reliant on specialized tooling and high injection energy for an enhanced erosion capability, maybe up to 5 meters diameter. See what is that erosion capacity? It is in terms of the diameter of the column that we are thinking. So if you have a superjet system, it needs about 5 meters, it can create 5 meters diameter columns. Think of very soft soil, Japan, and many places of course in India. This is the way that they have been doing it. Like we know some institutes in Saga and other places, soil is so soft, so they have to go for advanced ground improvement techniques like this. XZ system, a triple fluid system using a pair of colliding erosion jets to create a more uniform and controlled diameter of the treatment. They have a colliding jets here, that is the difference. So what I would like to show to you is that the ground improvement has been a very versatile technique and has been proven to be suitable to many ground improvement applications, and these are all the references that I have followed for this. Before I just conclude, I think we should just have a look at some of the videos that we have done again, so that it enhances your understanding here. Like as I just mentioned, this is a single one. Of course, as I just mentioned, this was done in India also by Keller and other group of companies. There are companies doing business in these lines. You can see grout and air coming. You can see that the spoil, whatever is the spoil that can come out with that is also there. So you have air, water and the grout. Yeah. You can also have a look at the compaction grouting. The way it does things. Here you can see that it is somewhat slower, as I just mentioned. The pore pressure mobilization, dissipation, they are all quite important. Like it has a different way of you can see that they Thank you.